Good day guys, welcome to my YouTube channel. So today we are going to talk about how inverter works, how it changes DC current to AC current. Firstly, what is DC current? DC means direct current, and it is the current that moves in only one direction, while AC current means alternating current. It is the type of current that changes its state, like alternate. It moves from one state to another, like moves from negative to the positive and positive to negative. And what is inverter? An inverter is a power electronic device that changes DC current to AC current. This is done by, if you look at this block diagram over here, this is the DC input going to the oscillator and then to the driver stage and then to the step-up power transformer, and then the power from the 220 volts from the transformer is now filtered from the filter section, and then it is now here. This is the 220 volt AC now in usage. Now let's see how inverter works, how it converts DC current to AC current. Over here, this is the DC current. It moves in only one direction, like this, just in one direction. It moves in one direction and now changes the DC current to the AC current. This is the type, we call this sine wave. This is one of the waves that is produced from AC current. This is the sine wave. Now let's talk about the frequency. What is the meaning of frequency? Frequency is the number of waves that pass a fixed point in a unit time. Like now, let's see now, this is 1 hertz. The reason why it is called 1 hertz is it moves from 0 here to positive and then to negative and then to 0 back. That is one cycle, and that is 1 hertz. The unit for frequency is hertz. Now this is 2 hertz. It moves from 0 to positive and then to negative to positive, then to negative and then to 0. Like that is two cycle. The first one stops here and the second one stops here. Now let's see how inverter convert the DC current to AC current. So that is done by switching the switch here. You can see switch 1, switch 2, switch 3, switch 4. So here, this switch 1 and switch 4 will work together. This switch 2 and switch 3 will also work together. If this switch 1 and switch 2 is turned on, switch 1 and switch 3 and switch 2 and switch 3 will remain off. If this switch 2 and switch 3 is turned on, this switch 1 and switch 4 will turned off. So by that, the phase of the wave will be changing as the switch is being on and is being off. The wave will be changing like that. So let's see here. If we switch on the switch 1 and switch 4 and we power it with a 12 volt DC battery, the positive voltage will comes here like this. It will pass through switch 1, like, because this switch is being open, so it can't pass here. It will only pass through this place like this. It will go to the bulb and then comes back like this. It will flow through this switch 4. So here, because this switch 2 is open, it can't pass through this place. It will only pass through this place like this and then goes back to the negative of the battery. So in that case, this DC is only moving like this, and this now is moving like this and then coming back like this. So when this place is positive voltage, this place is negative voltage. So here, if you now close the switch 1 and switch 4, if we open the switch 1 and switch 4, and we now close the switch 2 and switch 3, the positive voltage will pass through here. It won't be able to pass through here again because we have opened the switch 1. So it will only pass through this switch 2 and then goes back here and then comes back again. Then it will come back again here like this. It won't be able to pass through switch 1 again. It will now pass through switch 4 and then goes back to the negative here. So here this place will now be negative and this will now be positive. Here this place is positive, this place is negative. Here this place is negative, this place is positive. So you see now that the signal is changing. When this place is positive, this place is negative. When this place is positive, this place is negative. The signal will be changing, and this signal will remain, it will remain in one direction, and this place will be in two direction like this, going coming here and then going back. It will be shifting like that. So when the signal is being changed, so we can get a square wave, modified sine wave, and a sine wave due to the driver of the circuit. So now let's see how the low voltage is now being stepped up. So when the switching is being done repeatedly, we can now add a step up transformer to step up the low voltage 12 volt AC from the switch, and it cannot be changed here through the 220 volt side like this. The transformer will now step up, it will step up the 12 volt, it will step up the 12 volts coming from this switch here. It will step up to 220 volts AC for appliance. So now if the switching happens 100 times within 1 second, you can get 50 Hz, and if it switches 120 times in 1 second, you will get 60 Hz. So by that switching, and we can get the switching through, we can instead of using a switch here, we can apply a MOSFET here. A MOSFET is a metal oxide semiconductor field effect transistor. It is used to switch on and off a circuit super fast, like 100 times within 1 second. So that's why we use a MOSFET or IGBT to switch inverters. Now, the reason why we use a step-up transformer is to step up the low 12V AC voltage from the switching. It is to step up the voltage to 220 volts AC for the appliance to work. Now let's talk about oscillator. What is an oscillator? An oscillator can be defined as a device that provides waveform as its output power. Now, if this 555 IC is being powered with a 5 to 15 volts DC input, it will provide a square waveform output here. So if this output waveform is now connected to the switch over here, it will provide a square waveform for the transformer, and we will now get 220 VAC square wave output here. So we can use so many IC for our oscillator. We can use 3525, we can use 3524. So 3524 and 3525, they have some features that this 555 IC doesn't have, like feedback feature and frequency setting feature. So we can set the output frequency of the output of the 3524. You can set the output voltage with the feedback voltage, so that when anything is plugged into the inverter, the voltage will not drop down. So you can use a feedback for the IC. So now let's talk about this MOSFET. A MOSFET is used for switching in the circuit of inverter, because we need this to be switched to be on and off in 100 times within a seconds. So no one can start to be switching a circuit now because we want to get a AC voltage. So now we have to use, we can use IGBT, or we can use a MOSFET, because they can switch and they can open and close a circuit super fast, like 100 times within a second. So now this is the gate, this is the drain, and this is the source. We use this gate to open and to close the circuit, and a negative voltage can pass through here and then to this place if we switch it here, and we can even use a positive voltage through here and it can pass through here if you switch on the gate here. So in inverter now, we use this we use a negative voltage to switch. No, sorry, if we are using a center tap transformer, we will have to use a positive voltage to control the switch here, because we are powering this MOSFET with a negative voltage. So if a negative voltage is being plugged here, it can't come directly to the drain until we switch it here with the gate. We can apply voltage like from 1.5 volts to 1 volt here, because if we apply more than that, it can burn the MOSFET. And the full meaning of MOSFET means metal oxide semiconductor field defect transistor. We use this type of transistor to switch on and to switch off the circuit 100 times within a seconds, and that is awesome. Let's look at just a simple calculation on inverter transformer. Like now, this transformer is rated for 12 volts input here and then 220 volt output. That is the secondary winding. So to calculate the current of the transformer now, the secondary input, this transformer is rated for 1000 watts. So here we will divide the 1000 watts divided by 220 volts and we now get 4.54 amps. Likewise here, 1000 watts divided by 12 volts, we get 83.33 amps. So if we want to calculate the power again, we will now multiply this 12 volts here, multiply by 83.33 amps, we will get 999.96. If we approximate that, we get back our 1000 watts. So likewise here, same thing applies here. So in our next video, we will see how we can calculate the turns per volt of our transformer and other calculations on inverter, how we can construct our MOSFET bank. Make sure you like and subscribe to our YouTube channel. Thanks.